Designing a factory by leveraging an integrated factory model through every phase of the factory lifecycle has a positive impact on your time to market, time to volume, and your overall equipment efficiency. That means you are able to sell new products sooner, increase throughput, and run the factory in a more cost-efficient manner. That helps to solve business issues that companies have today with shorter product life cycles and satisfy market needs for individualized products. 2D drafting techniques and Excel calculations are commonplace for laying out the factory floor. The complexity increases due to multiple success factors and involves every discipline in the factory. Therefore, these commonly used 2D toolsets are not effective enough to solve future critical business issues. The capabilities of planning the virtual factory has evolved over the years. Having an accurate 3D model of the existing factory at any time in the factory lifecycle helps to make informed decisions in every lifecycle phase for plan, build, and operate. We at Autodesk call this integrated factory model the single version of truth of a digital factory. During the workflow of factory planning, we are using different authoring tools, specific for the requirements of the persona, by creating one model. In the plan phase, 2D capabilities are working well for the layout designers to conceptualize multiple scenarios for effective decision-making. Process flow simulations, rough layouts, and material flow optimizations are deliverables we can create in AutoCAD. Factory owners are able to create better specifications. Equipment suppliers benefit by having a better understanding of the equipment and design so they can come up with compelling sales proposals in the bidding process by using the integrated factory model. First of all, let's take a look at Process Analysis 360, a web-based product that helps manufacturing engineers and system designers model, study, and optimize the manufacturing process concept. Take advantage of existing data from the shop floor to populate the study, or use the toolbar for dragging new block diagrams into the workspace. In this example, the engineering team is challenged with a more individualized and flexible demand for the VMech ATV, which leads to the need for increasing the throughput. The current process of manually welding the chassis isn't going to be enough. The VMech engineer is creating a specification for a request for proposal, including a rough layout and throughput definition of the process concept. As soon as the equipment supplier delivers an existing weld cell's 3D model and process data, adapted to the space requirements with the proposal, the VMech engineers can seamlessly integrate an associative model. To validate this proposal, the manufacturing engineers can analyze the welding process to identify any bottlenecks and ultimately determine how many chassis can be produced in a specified period of time. After running the solver, it looks like a single weld cell isn't going to be enough to meet demand. Let's try 2 weld cells simply by copying the existing process and rerun the analysis. As you can see, making modifications to the processes and transportation modes is fast and easy, and it can be done early when making changes is the most affordable. We can see the 2 weld cells are going to be enough to get the job done. Taking a look at a report, we can see in detail the utilization of processes and buffers. Is the equipment ever blocked, idle, or is there any downtime for a machine? This HTML report can be saved for a joint design review with VMech and supplier engineers. Now that our welding process has been approved, we can repurpose the data and use it directly in our 2D layout. Save it off as a DWG and insert it into our existing factory. Then use standard commands to create the other weld cell and position them appropriately. As we move the weld cells into position, we can ensure there is no interference with the walls and structural members within the building. Additional factory assets can be dragged in using the same exact library we saw in Process Analysis 360. Here we have a series of cable trays. Chained assets are a great way to include items such as conveyors, guardrails, pipe, conduit, safety fence, and more. There is another way of connecting factory equipment. For example, here we will add a couple curved and straight conveyors to the welding cell. Many of the assets contain connectors for fast and easy placement without the need for O-snaps. Simply line up the green dots on the asset to position the equipment. Now that we have included the new welding cells in the design, let's take a look at it in 3D. It's just a click of a button away in AutoCAD. Remember, there is bidirectional associativity in 2D and 3D. Make changes in either environment, and they will remain in sync. In this case, we need jib cranes to transfer the chassis components from the conveyor to the indexing table. All the assets recognize the floor, and additional options are available directly on the asset triad for rotation and translation of the equipment. Stakeholders will benefit from a virtual walkthrough of the facility. By establishing a manufacturing change management process to detect and fix clashes, and front-loading the validation digitally helps to avoid costly failures and reduces the need for a contingency budget. As new equipment is added within the 2D or 3D environment, Navisworks will immediately reflect those changes. There is no better way to dynamically visualize the virtual factory by incorporating a digital mock-up. Mechanical and manufacturing engineering teams can now collaborate effectively and efficiently make more informed factory layout decisions before any equipment is installed. Even take advantage of scanned point cloud data from the existing facility to ensure the equipment doesn't interfere with overhead building structures, I-beams, HVAC, or piping. If there is a problem, then remember modifications can be made in the 2D or 3D environment. Change the properties of the existing equipment or try other options from the factory asset warehouse. When it comes to installation and commissioning, we can take advantage of the drawing capabilities for documenting the layout. 2D drawings are fast and easy. Simply select locations for desired views. Even change the scale of the views by dragging the border or change the view orientation using the view cube right on the sheet. Display the isometric view in color for better collaboration with those who have a difficult time reading 2D drawings. Produce a bill of equipment automatically. As factory assets are added or removed from the design, the parts list will update accordingly. Even add the balloons for the equipment, which is just a few button clicks away. Now that the factory equipment is planned out, we begin the install and commissioning process for the new factory layout. With the planning tool, we can manually add the items, but we found that many organizations want to open up the install planning to a larger team. Thus, tools like Microsoft Project, or in our case Excel, can be used to develop the install plan. Our plan is to install the tables, followed by the robots, controller, safety equipment, conveyor, and finally the cranes. After adding the spreadsheet into the plan, we can connect each item to the factory asset. And finally, animate the sequence. Here we can scrub the timeline or play through the video. Once the team is comfortable with the process, we will capture the animation and share the AVI for everyone to open and review as needed. After successfully ramping up the production, the integrated factory model is handed over to the owner or operator. In this phase of the factory lifecycle, we can leverage the integrated factory model by linking master data to the geometry. Master data such as processes, setup, and downtimes of the factory assets can be linked back to the digital mockup. Maintenance engineers can leverage this to find the right spare parts, having all documentation at hand, and can make informed predictive maintenance decisions using historical data in combination with a 3D model. Manufacturing engineers can manage manufacturing change requests and prioritize these to gain the best possible improvement with the allocated resources. We can show real-time and historical data in the 3D environment to help them make informed improvements or retrofit decisions for the next version of the factory. If we have a digital mock-up of the factory, we are able to gain advantages for the IoT or Industry 4.0 concept. With having a 3D model used in the operate phase, we have an accurate integrated factory model at any time. We ensure a closed-loop integrated factory model because we can feed back information and experience to the plan phase of the next factory or production line. A seamless information flow. Autodesk Factory Design Suite is a complete workflow. Analyze your processes, strategically position and validate the equipment, and plan for installation as well as operate the factory. It is your trusted solution for an informed factory layout. It is the future of making things.